are there some other books from where we can practice?
For cobweb model, you will get 2 or 3 numerical exercises in Henderson and Quant 2 for the
Okay.
cobweb. Okay,
Okay. Yes.
so
Thank you.
yeah, 2 or 3 problems you will get there. At the honors level, actually, you need to understand the nitty-gritty is the way you have to do these things. It's very difficult to find out so many numerical exercises on a same topic, so you will not get the things like that. However, you have to grasp the matter. You have to understand the things. And for practicing purpose, you will get, 8 to 10 problems. Okay, so check all these things. So today,
Okay.
again, going to tell you a model which is based on first order difference equation. The technique just we have learned the first order difference equation. Now this time, this is also based on the market economics. So this is based on demand and supply framework. However, the difference of today's model compared to the cobweb kind of thing will be, we will not introduce any lag in the supply equation. We will not introduce any lag in the supply equation. Rather, we will consider the notion of inventory or stock. So today's model will be based on the idea of inventory or stock. Now, just in the last month before the Poila Boishak, the first day of the new Bengali year, you got the advertisement, so many sales kind of thing, So 50% discount, up to 75% discount, clearing the sales, clearing the old things, So many a times, if you look at the market, Amazon, Flipkart, Big Bazaar, so everybody is advertising 50% discount for clearing the sales, okay, and or up to this discount for clearing the sales, okay. So today's model is based on that concept. So if there is any stock, in that case, suppose there is a stock in T-1th period. So that stock in T-1th period will determine what will be the price of the commodity in the next period, that is in the Tth period. If there is any positive stock in T-1th period, immediate before the period we are considering, in that case, there will be a reduction in price. On the other hand, if there is negative stock, that is actually producers faced lesser supply in the last period. In that case, there will be an increase in price. Now, how I'll measure the stock? It is the difference between supply and demand. Okay. So far, when we discussed about the cobweb models, etc., we talked about, or we started with the excess demand minus supply. For this model, we will start with supply minus demand, because supply minus demand measures the stock or the inventory. If the supply minus demand is positive, that means there is a positive stock. There is a positive inventory. So if there is inventory accumulation in T-1th period, that will result in reduction in price of the commodity in the Tth period. On the other hand, if there is inventory decumulation, that means suppliers found that demand is greater than supply. Their supply is less of that of demand. So negative decumulation. So if that is the position, in that case, in the next period, they will increase the price. So controlling mechanism of the price will be in the hand of suppliers. And this controlling mechanism will be fully operated on the basis of whether there is inventory accumulation or positive stock, or whether there is inventory decumulation or negative stock. Are you understanding the principle of price adjustment in this market model? Any question, any query? Are you understanding what is the meaning of inventory? You know, whether
Ma'am, your voice is getting disconnected.
my voice is getting disconnected, everybody is facing that.
No, ma'am.
So I think Konkona, there is some problem with your connection. Okay, so please check it, because I am finding my line is very.
So, ma'am,
Yeah.
will I leave and join again?
Yeah, I think so. I think so. Okay, anyone? Any question regarding inventory accumulation, inventory decumulation, positive stock, negative stock, how positive stock can determine what will be the price in the next period? Any question regarding this? Anyone?
Ma'am, what is negative stock?
Negative stock, as I mentioned, if in the last period suppliers find that demand is greater than supply, demand is greater than supply. Okay, so in
Okay.
this, here we are measuring the stock as supply minus demand, supply minus demand. So positive value means supply is greater than demand, negative value means supply is less than demand. Okay, so in the last period, if supply is greater than demand, that means there is a stock of commodity. In the next period, there will be a reduction, discount, 50% discount, 25% discount, up to 70% discount. All these discounting factors you will find while the price will be set in the market. As I mentioned last month, everybody checked. In fact, now on the regular basis, you will find that, different organizations or markets are giving different types of discounts, and they are telling these mechanisms, selling the past accumulation, selling the past stock at a lesser price. Okay, so
Yes, ma'am.
yeah, supply is greater than demand means positive stock, supply is
Hmm.
less than demand, that means
Negative
negative.
stock.
Okay,
Yes.
and if
Yes.
suppliers find that the demand for the commodity is higher than whatever I am supplying, in that case, in the next period, they will increase the price.
Okay,
Okay,
okay, ma'am. Yes, ma'am.
Ma'am, so when there is positive stock, then they give the big discount.
yeah. When there is a positive stock, inventory accumulation, because commodities will become, of old fashion. So every day, every consumer wants the new product, okay, new variety. So if there is a stock, the color will be faded, the style will be bit backdated. So all these problems are there, and when you will go to the shop, you will not like to purchase these things, or when you are visiting different online shops, you will not order for this kind of commodities. You can order for this kind of commodities if and only if you get sufficient discount. Okay, in that case, you are getting some incentive that you can buy this commodity, bit old fashioned, but you will buy it because there is a lot of discount. Okay, there is a lot of discount. So this is the idea. If there is a stock in T minus 1th period, price will fall in Tth period. If there is negative stock in T minus 1th period, then price will rise in next period. So suppliers are adjusting the price in following this mechanism, following the mechanism of whether there is an inventory accumulation in the last period or inventory decumulation in the last period. Everybody got the idea? If we understand the idea, after that, we have to go for mathematical model building exercise for this kind of market. Okay, so this is second application of first order difference equation, where we are going to discuss a market with inventory. A market with inventory. Inventory means stock. In the preceding model, price is assumed to be set in such a way as to clear the current output of every time period. Demand is equal to supply. dt is equal to st. We are setting dt is equal to st in cobweb type of framework. So at every period, you want that the market should be cleared, or pricing will be such that the market is cleared in every period. The implication of that assumption is either that the commodity is a perishable which cannot be stocked, or that though it is stockable, no inventory is ever kept. Now we shall construct a model in which sellers do keep an inventory of the commodity, where there will be the notion of stock. In the earlier model, there was no notion of stock. Market is cleared in every period. However, in this model, we are allowing the sellers to keep an inventory. Okay, because cobweb type of model is generally very much applicable for the perishable commodities. However, all the commodities in reality are not perishable. So we need to discuss some other model which will help us to capture the reality. So for building this model, we will consider three assumptions. So let's assume the following. Number one, both the quantity demanded, that is QDT, and quantity currently produced, QST, are unlagged linear functions of price PT. So QDT is a function of PT and QST is a function of PT. We are not introducing any lag here. In the cobweb model, QDT was the function of PT. However, QST was the function of what? PT or something else. In a cobweb model?
PT minus 1.
PT minus 1. So there was a lagged functional relation between QST and price. Here we will not consider that. Second assumption, the adjustment of price is affected not through market clearance in every period, but through a process of price setting by the sellers. As I mentioned, here we will not consider the clearance of market at every period. Rather, we are considering another mechanism. By that mechanism, sellers will dictate what will be the price of the commodity. At the beginning of each period, the sellers set a price for that period after taking into consideration the inventory situation. If, as a result of the preceding period price, inventory accumulated, price was high, and therefore there was insufficient demand for the commodity, and for that matter there is inventory accumulation, the current period price is set at a lower level than before in order to move the merchandise. But if inventory decumulated instead, the current price is set higher than before. So as I mentioned, if there is an inventory accumulation, that is supply was greater than demand in the last period, then in the current period, there will be a reduction in price. Supplier will try to give some incentive to the buyers so that at least, a major portion of stock is cleared. Okay, major portion of stock is cleared, if not the entire amount. So naturally, the price will fall in the current period if there is a stock in the last period. On the other hand, if suppliers feel that in the last period demand was higher than supply, which we indicate using the term inventory decumulation in inventory or negative stock, in that case the current price will be set higher than before. So in the current period, price will be higher. Third, the price adjustment made from period to period is inversely proportional to the observed change in the inventory. I'm repeating, the price adjustment, that is where the price will increase, that is inversely proportional to observed change in inventory or stock. If there is positive inventory, there will be reduction in price. If there is negative inventory, there will be an increase in price. So positive stock positive stock indicates price will fall. Negative stock indicates price will rise. Okay, so this is the idea. Hence, there is an inverse relationship between the price and the inventory, price and the stock. Price is inversely related to, or price adjustment is inversely proportional to the observed change in the inventory. So here we are not considering the price adjustment following the excess demand principle. We are not considering the thing in that way. Okay, as we did in case of static stability condition, or as we did in case of cobweb, we are not following that principle. Price will be not guided by excess demand principle. Rather, price will be guided by whether there is a positive stock or whether there is a negative stock. Okay, so suppliers are controlling the price looking at inventory accumulation or inventory decumulation. In other words, excess supply, not excess demand. Rather, excess supply will indicate whether price will fall in the next period or price will increase in the next period. Any question regarding these three assumptions? Any point, any question? Is it clear to everyone? It's fine?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So if this is fine, next we have to present the idea using several equations. So I hope everybody has pen and paper. So from this point, you need to write the equation so that we can frame the entire analysis. So with these assumptions, we can write the following equations. Q dt is equal to alpha minus beta pt. Both alpha and beta are positive. So it is a negatively sloped demand curve having a positive intercept alpha, standard demand curve. Okay. So if I draw the diagram of the demand curve, it looks like this. This intercept is alpha and this is beta. Okay, minus sign indicates the curve is negatively sloped. The second equation is QST is equal to minus gamma minus delta PT. Okay, minus gamma minus delta PT. Okay, both gamma and delta positive. So supply curve, just a minute, let me check.
Why delta is here?
Yeah, just let me check whether there is a typo. Let me check that. Okay, for the time being, I'm not understanding. As you will proceed, I'll understand, okay? Whether really I wanted to mean minus delta or just wrongly I have mentioned the sign to be minus. Okay, so for the time being, please write down the supply equation as QST is equal to minus gamma plus delta PT. There is no harm if the supply curve is negatively sloped. However, I think I didn't start with that. So this is the supply curve in that case. Minus gamma plus delta PT, the supply curve will look like this. It's a positively sloped supply curve having an intercept in the having a negative intercept, okay? Having a negative intercept. Call it equation number 2. Then I am considering the price of T plus 1th period. T plus 1th period. T plus 1 is equal to PT. That is, the price was there in the last period. Minus sigma into QST minus QDT. Supply minus demand, QST minus QDT. Where sigma is positive, sigma is greater than 0. Sigma denotes the stock induced price adjustment coefficient. Please note down, sigma denotes the stock induced price adjustment coefficient. Okay, so if QST minus QDT is positive, that means there is inventory accumulation. If this part is positive, which means in that case, price of T plus 1th period will be less than that of price of the Tth period. Price of T plus 1th period will be less than price of Tth period, okay? So, price of T plus 1th period will be last period's price minus something. Last period price minus something. So price will be lesser. On the other hand, if this QST minus QDT, this term is negative, that means demand was greater than supply in the last period. This sign will be positive. So PT plus 1 will be greater than that of PT. PT plus 1 will be greater than that of PT. Okay. So, in general, we will write the equation as PT plus 1 is equal to last period's price PT minus sigma into QST minus QDT. Whereas I hope you are understanding, sigma is indicating stock induced price adjustment coefficient. If there is positive stock, sigma will operate in one direction. If there is a negative stock, sigma will operate in the reverse direction. Here, I'm mentioning that in case of the earlier problem, that is in case of the cobweb problem, we consider excess demand as the mechanism of price adjustment. However, here we consider excess supply as the mechanism of price adjustment. In the previous case, we considered excess demand as the mechanism. Here, we are considering excess supply as the mechanism to adjust the price in the market. So these are the three equations with which we will begin our operation. Now, what is our objective? Our objective is to find out so the same thing we want to do. We want to find out the time path of price, how price moves for say last 10 periods, how price is moving for say last 5 periods. Okay, so this is the thing. We will like to find out the time path of price. We will like to find out PT. Now, to find out the time path of price, what we will do, we will plug the demand equation and the supply equation in equation number 3. We will plug the demand equation and the supply equations in equation number 3. As we do so, we will find some values related to PT plus 1, some value related to PT, because both in the demand and the supply equations we have PT, and there will be some constant term. So we will have PT plus 1 and PT and constant in our equation. So I hope you are understanding. We will be able to construct a first order difference equation in P. First order difference equation in P, because there will be the term related to PT plus 1 and there will be term related to PT. So there will be one period lag between the two time points, and we will be able to therefore generate a first order difference equation in PT. So I'll tell everybody to plug the values of the demand and the supply in equation number 3. So please write down, plugging equations 1 and 2 in equation 3, we get, plugging 1 and 2 in equation 3, we get PT plus 1 is equal to PT minus sigma within bracket minus gamma plus delta PT minus alpha plus beta PT. Then take PT common. Take PT common. There are 3 PT in your model. In your equation, there will be 3 PT. So take PT common and generate a first order difference equation. You will have PT plus 1, you will have PT with coefficient, and you will have a constant. Everybody is understanding what you need to do? Any question? Is there anyone who is not understanding what you need to do? Are you doing the things?
Yes, ma'am.
Please let me know once you get the first order difference equation.
Ma'am, got it.
Yes, ma'am.
Got it?
Yes, ma'am.
So
Yes,
see,
ma'am.
you got this equation?
Yes, ma'am.
Yes, ma'am.
So there was a typo in the supply equation. Okay, so please continue with plus gamma. The supply equation will be minus gamma plus delta PT. So I hope everybody could complete up to this. PT plus 1 minus 1 minus sigma into beta plus delta into PT is equal to sigma into alpha plus gamma. Okay, so once we get this equation, first order difference equation in PT, we have to find out the solution, or that means we have to calculate the time path. Time path will look like this. However, you have to complete all the steps. Okay. So once you get this thing, please add this is a first order difference equation in PT. Next, the time path of the price is given by next line, PT is equal to CF plus PI. Complementary function plus particular integral. Next, to get the PI, particular integral, we consider PT plus 1 is equal to PT is equal to PE, where PE is the intertemporal equilibrium price. Where PE is the intertemporal equilibrium price. Call this equation number 4. And this equation number 5. So substituting 5 in 4, find out P, substitute 5 into 4 and find out PE. Prithviraj, what is the value of PE?
So I am finding.
Okay.
Ma'am, I've got it.
Yeah, please tell me.
Gamma by beta plus delta.
Alpha plus gamma by beta plus delta. So everybody please check whether you are also getting P is equal to alpha plus gamma by beta plus delta. If you get different value, please let me know.
No, ma'am, we got the same.
You got the same. Very
Yes,
good.
ma'am.
Okay, so P,
Yes, ma'am.
okay, and this is equal to the required PI. And this is equal to the value of the particular integral. Okay. Now to derive the CF part, what we will do?
Take the homogeneous equation and the trial solution.
Sigma into
Trial
alpha plus gamma किसी को दे दो.
Homogeneous equation, very good. So please write down. To derive the CF complementary function, we consider the trial solution. We consider the trial solution Pt is equal to a b to the power t for the, we consider the trial solution Pt is equal to a b to the power t for the homogeneous form, of equation 4, for the homogeneous form of equation 4 given by so what will be the equation? Homogeneous form given by
Pt plus 1 minus delta into beta plus
1
1
minus
sigma into beta plus delta bracket close Pt equal to 0.
yes. So we write the left hand side of equation number 4 and we will set the right hand side to be equal to 0. Okay, so in that equation, please put Pt is equal to ab to the power t and Pt plus 1 is equal to ab to the power t plus 1. And find out the value of b.
And b is 1 minus sigma into beta plus delta.
Please check, everyone, please check whether you are getting the same value for b.
Yes, ma'am.
Yes, ma'am.
Okay. So the trial solution, if you get this value, this is the value of b. Hence, the trial solution, or you please write, hence the CF is equal to this. Thus, the time path of rise, is given by Pt is equal to Cf plus Pi so everybody could reach up to this. The time path of rise is given by Pt is equal to A into 1 minus delta, sorry, 1 minus sigma into beta plus delta whole to the power t plus alpha plus gamma by beta plus delta.
Yes, ma'am.
Yes, ma'am.
Question number 6. So in the next step, what we will do?
Find A.
Find A. Yeah.
T will be equal to 0. A
0.
minus B.
Yeah. Very good. So please write down. To derive the value of A in equation number 6, we set
Ma'am, my B, to the power C coming in B for the bold writing.
just
Like
would you once again?
where is the I don't understand how this to the power C is coming for B in the bold writing. B equals to 1 minus sigma beta plus
Delta.
gamma. Yeah, let B equals to that there's a to the power C.
It's a typo actually.
Not B. B is 1 minus to the power is not there in the B value. আমি ক্লাস নিচ্ছি তো এখন আমি পরে কথা বলবো No, the T will be not there. I told you to solve the thing, so I am not checking what is there in my part, because already B is there.
Yes, ma'am. Then it's correct. I suddenly looked at the slide and got confused.
Yeah. So everybody could reach up to equation number 6, and then you are setting T is equal to 0.
Yes, ma'am.
Yes, ma'am.
So if I set T is equal to 0 from, in equation number 6, what is the value of A?
Ma'am, P0
Not minus A plus
Minus alpha
gamma
plus
divided by
gamma
beta
by
plus
beta
delta.
plus delta.
This one?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Hence the time path of price. Hence the time path of price is finally given by Pt is equal to P naught minus alpha plus gamma by beta plus delta into 1 minus sigma into beta plus delta whole to the power T plus alpha plus gamma by beta plus delta, the equation which is stated here. So this is the final form of the time path. So please check everybody whether you are getting this or not. So once you get this, call it equation number 7. Hence finally the time path of price is given by equation number 7. Any question? Everyone got it?
Yes, ma'am.
Yes. Yes, ma'am.
Yes, ma'am.
Rona got it?
Yes, ma'am.
Okay. So once we get the time path, so we just here we generated the time path of price. So once we get the time path of price, the next task will be to check whether the time path is convergent, divergent, what are the conditions of convergency, when the time path will be divergent, when the time path will be monotonic, when the time path will be oscillatory. So all these considerations will come. Okay, so what will be the exact nature of the time path of price? Now we have to go for that part. Once you understand how to derive the time path of price, in the next step, we need to understand how we will analyze the stability condition of this time path and how we will understand whether the time path will be oscillatory or whether the time path will be monotonic. Now look at the equation, look at the last equation, that is equation number 7. If you look at this equation, this part is nothing but PE. Okay, so the path will be dynamically stable if PT tends to PE as T tends to infinity. The time path will be dynamically stable if PT tends to PE as T tends to infinity. Okay, and for that matter, actually you need this entire term should move towards 0 as T tends to infinity. This entire term should move towards 0 as T tends to infinity. That you need. If you want that PT should tend towards PE as T tends to infinity, actually you need the first term should tend towards 0 as T tends to infinity. Now in the first term, there are two components. The first component is P naught minus alpha plus gamma by beta plus delta, or the first component is P naught minus PE. This is the first component. Okay, this first component is P naught minus PE. Both P naught and PE are constant. Okay, so this part cannot move towards 0. It is a constant. The difference is a constant. Hence, if we want that this first term should move towards 0, what we need that this term basically, this term should move towards 0. This entire term, that is the B, this B should move towards 0. Now this B should move towards 0 if and only if the modulus B is less than 1. Modulus B is less than 1, or mod of 1 minus sigma into beta plus delta. If this is less than 1, in that case, as T tends to infinity, since it is a fraction, you know, the denominator will go on increasing, and for that matter, this entire mod B, or B to the power T rather, that will move towards 0. If mod B is less than 1, as we are go on increasing the power T, the fraction is becoming smaller, smaller and smaller, and for that matter, this entire term will move towards 0. This entire term will move towards 0 as T tends to infinity. So the first term will vanish and PT will move towards this equilibrium value alpha plus gamma by beta plus delta. Okay. Any question, any query regarding the stability condition? Everybody is understanding this?
Yes, ma'am.
Rest of the students understanding what will be the stability condition?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
This is very, very similar to the last one.
Yes, ma'am.
Consider the stability condition. This is very, very similar to the last one. So if you understand the stability requirement, in the next step, you need to understand whether the time path is monotonic or whether the time path is oscillatory. That part you need to understand. Okay. Now look at the first line. As sigma, beta, and delta are all positives, B cannot be greater than or equal to 1. The value of B cannot be greater than or equal to 1. So let us come back to the B value. B value is 1 minus sigma into beta plus delta. 1 minus sigma into beta plus delta. That is the value of B. We are telling that sigma, beta, delta, everything is positive. Okay? Everything is positive. You know? beta, sigma, delta, all positive. So given all these values are positive, this B value cannot be greater than or equal to 1, because if you want this value to be equal to 1, this part should be equal to 0. Everyone?
Yes, ma'am.
Okay. So you are subtracting a non-zero positive value from 1. You are subtracting a non-zero positive value from 1. So B should be always less than 1. B should be always less than 1.
Yes, ma'am.
Yes, ma'am.
Always it should be less than 1. Because you are subtracting a positive factor from the value 1, a positive element from the value 1. So B should be, remember here, always less than 1. B should be always less than 1. It can be negative. It doesn't mean modulus B is always less than 1. Okay, it can be negative. It can be positive. However, the B value should be less than 1. The B value should be less than 1. Less than 1 means it can be less than 0. Less than 1 means it can be less than 0. However, it cannot be greater than or equal to 1. This option is not there, which was there in the previous model. B can be equal to 1, B can be greater than 1. So these options are not there in this particular model. Okay, the B value is always less than 1. So all the possibilities which are less than 1 should be considered in this particular model. All the possibilities, all negative values, 0 values, and the positive values in between 0 and 1 will be considered for B. However, the positive values which are beyond 1 or greater than equal to 1 should not be considered for B. Okay. The first possibility, B can be greater than 0, less than 1. B can be greater than 0, less than 1, like half, 1/3, 1/5. It can take this value. B is less than 1. So one possibility is B is lying between 0 and 1. Now, if B lies in between 0 and 1, in that case, the B value is positive. Now, if B value is positive, the time path will be monotonic in nature. If this B is positive, in that case, the time path will be monotonic in nature. So time path will be monotonic. If B is positive, that it lies in between 0 and 1, time path will be monotonic. And in this case, modulus B less than 1, this condition is also satisfied. Modulus B less than 1, this condition is also satisfied. So for that matter, you will have monotonic convergent time path of price. Monotonic convergent time path of price. So the first option, when B lies in between 0 and 1, in that case, number 1, B is positive, hence the time path will be monotonic. Number 2, mod B is less than 1, and for that matter, the time path will be convergent. So together the two conditions give us monotonic convergent time path of price. The second thing is B is equal to 0. The second possibility is B is equal to 0. If B is equal to 0 somehow, in that case PT is equal to PE. PT is equal to PE. So time path will remain at equilibrium. Third possibility is B lies in between -1 and 0. B lies in between -1 and 0. In this case, B is negative. If B is negative for the even power of t, you will get a positive value. However, for the odd power of t, you will get a negative value. So it will fluctuate around the equilibrium. It will go up and go down, go up and go down around the equilibrium. So you will get oscillatory time path. However, in case of third condition, we are getting mod B to be less than 1. We are getting mod B to be less than 1. So if mod B is less than 1, in that case, the time path is convergent. So since B is negative, time path is oscillatory. However, if mod B is less than 1, time path will be convergent. Together, the two conditions will give us damped oscillatory time path of price. Damped oscillatory time path of price. Case 4, B is equal to minus 1. B is equal to minus 1. As you know, if B is equal to B is negative, you will get the oscillatory time path. And here, mod B is equal to 1. Mod B is equal to 1, which means the equilibrium or the time path will neither come towards equilibrium nor it will go away from the equilibrium. So you will get uniform oscillations around the equilibrium. Uniform oscillations around the equilibrium. The last possibility is B is less than minus 1. So in this case, B is negative and hence the time path will be oscillatory. However, mod B that is greater than 1. Mod B is greater than 1 and therefore the time path will be divergent. The time path will be divergent. So together the two conditions, that is the negative value of B and the mod value is greater than 1, gives explosive oscillations. Give explosive oscillations. So if you look at the cases, what we are finding that here the monotonic divergent time path is not possible. Monotonic divergent time path is not possible. The possibilities are, it can be monotonic convergent, it can stay at equilibrium. For oscillatory, all three possibilities are there. You can have explosive oscillations, you can have damped oscillations, you can have uniform oscillations. Okay. So once you understand all these 5 cases, I hope you will be able to draw the time path for prices. In the first case, you draw the monotonic convergent time paths, the step function, the same step function as we did in case of cobweb model because our time is discrete. So in the first case, you know, if this is the equilibrium, we will get these are this kind of time path. In the second case, okay, so this will be the time path 2, you know, PT. This is also the time path. Third case, damped oscillator. Fourth case, uniform oscillator. And finally, and so on. Okay? Explosive oscillations. So you need to prepare the drawings for all these 5 cases. What will be the nature of the time path, etc. You have idea from the previous model. So please complete this part, adding the diagram or whatever point you need to add here, please add so and complete the entire note. Any question? Anything?
Ma'am, I was asking about the fact that there is a mechanism which determines price. If we look at it, the inventory as accumulation from the point of view of demand, then can demand not be the also be like the determining metric for price? Because then if demand is excess, then inventory is false.
Why you?
So,
Gita, every market has its own mechanism. Okay. When we consider the market clearing mechanism, we consider the excess demand principle as the principle we are considering. Now, here, typically, I am telling that here suppliers control the price. Okay. The same factors are there, no doubt. The supply is there, demand is there, no problem like with demand and supply equations. However, the mechanism is based on excess supply principle. Now, if you want to define excess supply, naturally the demand equation will come in your analysis. However, the logic building, if you think about the logic building part, here, when we talk in terms of the inventory, when we are saying that suppliers are controlling the price in the market, naturally, our focus will be on the supply side. Definitely there is a demand. Definitely excess supply means demand is less than supply. Definitely negative inventory means demand is greater than supply. However, every market has its own mechanism, and, the principle of the market may be based on excess demand principle. Principle of the market may be based on inventory accumulation, decumulation, because here the entire logic is coming through equation number 3. Demand equation is a standard, static type of equation. It's not even dynamic. Only the T component is there. However, nothing new is there in the demand equation or in the supply equation. Here, the entire focus is on, the pricing principle is entirely depending on whether there is any positive or negative stock. So when we are trying to define a market or market mechanism or pricing in a market in terms of stock, why should we explain this in terms of demand, negative of excess demand, Isn't it easier to explain the things calling it excess supply?
yes, ma'am, got it. Thank you very much.
Any other question? Any other query? So,
ma'am, can you please draw the one demand supply figure and explain the process?
here it is not a cobweb kind of thing. Here there is no question of drawing the demand and supply things. Here you have to draw only the time path of price. Here we are not considering any cobweb kind of mechanism.
Okay, ma'am. Okay.
Ma'am, we will be drawing all the 5 time paths, right? Like the ones you showed.
Time paths only. All possible for 5 pages. You have to draw the time paths. Nothing else.
Thank you, ma'am.
For all these 5 cases, you have to draw the time. Here, there is no question of considering the cobweb kind of thing. Here the principle is based on this idea, this idea. Equation number 3 is the most important part of this thing. This is the price mechanism. I hope everybody is understanding. Here you don't need to draw the demand curve and the supply curve, and you have to show the things in terms of stock adjustment. There is no requirement for this kind of diagram. Here you have to only draw the time paths for all these possibilities. Got it?
Yes, ma'am.
Yes.
Any other question?
No, ma'am.
Okay. So, having some idea about the applications of the first order difference equation, in the next step, we will move to an application of second order difference equation, higher order difference equation, second order difference equation. Now, the second order difference equation or the application of the second order difference equation is based on a macro framework. Both the first order difference equation was based on micro framework because we are considering a demand supply framework for both the cases, be it inventory adjustment process or be it market clearing process. Whatever be the thing, we considered a micro market there. To explain the application of second order difference equation, we will consider a macro context. We will bring the national income accounting equation here. Y is equal to C plus I plus G. Are you familiar with this equation?
Yes, ma'am.
Yes, ma'am.
What is Y?
Income.
Income.
National
Income.
So it is total output or total income at macro level. So it is national output or national income. Now what is C?
Consumption expenditure.
Consumption expenditure. I?
Investment
Investment
expenditure.
expenditure.
Very good. And what is G?
Government
Government
expenditure.
expenditure.
Okay. So we will consider Y is equal to C plus I plus G. This kind of framework. Now as there is C, later we can discuss the same model considering the savings too. Instead of consumption, we can bring savings also in our analysis because, you know, generally it is assumed that MPC plus MPS is equal to 1. Okay, MPC plus MPS is equal to 1. Generally we consider this framework. So whatever we are not consuming, that we are saving. So instead of C, we can also bring S in our analysis. However, to begin with, we will consider the standard national income accounting equation. Y is equal to C plus I plus G. So do you have the notion of, do you know the notion of multiplier? Idea about the multiplier?
No, ma'am.
You do not have. Okay. And you do not even have the idea of accelerator too.
No, ma'am.
No, ma'am.
I hope you will learn all these ideas, you know, especially the idea of multiplier within 1 or 2 macro classes. You know, you will get it. However, since we need the notion of multiplier, we need the notion of accelerator, we'll discuss the definitions of both. So we are going to have a third model building exercise, second order difference equation. The second order difference equation is basically Samuelson's multiplier accelerator interaction model. Multiplier will be there, accelerator will be there, and both multiplier and the accelerator will work together. And therefore, it is multiplier accelerator interaction model. They will interact with each other. They will be operative at the same time. Now, to begin with, this is a classic work by Paul Samuelson. The model seeks to explore the dynamic process of income income determination when acceleration principle is in operation along with the Keynesian multiplier. Are you familiar with the name of Keynes?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am.
Okay. So this is the context. Okay. So I hope you are understanding here. We have to find out the time path of national income, Y. So in the previous model, we derived the time path for P. Here we will derive the time path of Y. Okay, because this model seeks to explore the dynamic process of income determination, how income is dynamically determined. So one by one, let's try to understand what is meant by acceleration principle and what is meant by multiplier. Now look at the acceleration principle. If a population's income increases and its residents as a result begin to consume more, there will be a corresponding but magnified change in investment. So what I am telling, since you know the national income accounting thing, since you have idea about the consumption expenditure, can you tell me C is function of what?
A
Y.
plus
A plus B
plus
y.
A plus
B
B
y.
Y T. Y. Right now? C
Yes,
is
ma'am.
equal to
Yes, ma'am.
A plus B
Can
y.
we write C
A
is a
plus B.
function of Y?
Y.
Okay, so C is a function of income. So if a population's income increases, suppose somehow national income is increasing, production of an economy is increasing. So income increases and its residents as a result begin to consume more. Is it feasible that residents begin to consume more if income increases?
Yes, ma'am.
This
Yes,
is
ma'am.
possible because consumption is a positive function of income.
Yes, ma'am.
Okay. Do you have idea about the MPC, marginal propensity to consume?
Yes, ma'am.
Yes, ma'am.
B,
Yes,
the gradient, you know. In the
Hmm.
equation, you are telling C is equal to A plus BY. This B is the MPC, marginal propensity to consume. Okay. And we consider B to be, what is the range for B?
0 to
0 to
1.
1.
0 to 1. Yeah.
So B is greater than 0, less than 1. Okay, generally what we find that as in the beginning, when the income is at lower level, then the MPC is very high. And as income increases, in that case, MPC moves towards 0. So at the lower level of income, MPC is very close to 1. And at the higher level of income, MPC is close to 0. Do you know that? Do you know that?
No, ma'am.
Okay, so I'm telling you one thing. Consumption, it is true, is positively related to income. However, if you start with a beggar and moves towards multi-millionaire, okay, there are people of different income groups in our society. Poor, middle income group, you know, then rich, richest, different income groups. So what happens if you consider the poor or the income group which is below the middle income or up to middle income? What you will find that whatever the people are earning, mostly they are consuming. Whatever people are earning, their income is so small that almost the entire income will be consumed, if not the full amount. So if the entire income is consumed, in that case, if you consider dC by dy, change in consumption due to change in income, B actually is dC by dy, MPC is dC by dy, change in consumption divided by change in income. So for the poor people, what will happen? DC will be similar to that of dy, isn't it?
Yes, ma'am.
So MPC will be very close to 1, isn't it?
Yes, ma'am.
And as you are moving towards high income group, you will find that whatever they are earning, they cannot consume that amount. Only a very small fraction of their total income will be consumed, isn't it?
Yes,
Excuse me,
ma'am.
ma'am.
Dhirubhai Ambani, you know, and if you consider his income and if you consider his consumption, will it be similar to that of us?
No, ma'am.
Because consumption is fixed up to a certain level. How much you can eat, how much you can consume, how many cards you can keep, how many houses you can keep, you know. So there is a limit. You cannot go going on and on for consumption. Okay. So as you move towards a very high income level, you will find that only a very small fraction of changed income will come in the changed consumption. dC by dy will be very, very small and it is moving towards 0. Okay. So remember that though consumption is a positive function of income, for different income groups belonging to the society, there is a difference in this positive relation. For the high income group, this B is very low. For low and middle income group, this B is close to 1. Just a minute. Okay. So
Excuse me, ma'am.
any question?
Ma'am, B is calculated considering Y as national income. Why are we considering now subclasses of the
When
national?
you consider the consumption expenditure, it is the sum total of consumption expenditure of all individuals. Okay. So macro is based on micro foundation. So though we are considering the aggregate consumption expenditure, this aggregate consumption expenditure is the sum total of consumption expenditure of everyone. Okay. So within the macro, there are several micro layers, micro issues. So whenever you will try to capture the ideas which you are considering at the macro level, you have to understand all these micro issues too. Okay. So the standard thing is you are understanding consumption is a function of income. Okay. However, within this aggregation, there are several layers that you need to understand. Okay, MPC varies from one group to other. Okay.
Yes, ma'am.
Actually, the reason you are learning macroeconomics, you will be able to compare several countries. Say, actually, the countries are divided into several parts: high income country, you know, or very high income country, then high income countries, middle income countries, or we call these things developed world, developing world, less developed world. So all these terms and terminologies are there. Okay. So consumption income pattern at aggregate level too varies from country to country. Okay. So at the national level too, we need to compare what is happening in the entire universe. Okay, so if you follow the media, if you follow the newspaper articles, you will find that there are different groups of countries. Actually, we are dividing the countries into several groups. And then at the aggregate level, you need to understand for middle income country, what will be the MPC that will be higher compared to a group of countries which have very high level of income. Okay. So under macro, there are always micro issues, you know, under macro.
Ma'am, but we say that the consumption of United States is very high, even though its income is also very high.
Consumption is very high, that doesn't mean MPC is very high, isn't it? Your starting point may be very, very high. Okay, so let's try to understand the matter. Suppose I'm considering a graph for consumption and income. Along the horizontal axis, I'm measuring C, and along the vertical axis, along the horizontal axis, I'm measuring Y, and along the vertical axis, I'm measuring C. Okay, so okay, and this curve is very, very steep. You know, it is very, very steep compared to this one. Okay, however, your starting point is very small. MPC is very high for this country. However, the starting point is, you know, very small. And here, the consumption is more or less mildly increasing, you know, and starting point is very high. Okay? Got the point?
Yes, ma'am.
For this group of country, you know, MPC is very high. This curve is very steep. However, the starting point is very small. So whatever you are earning, you are mostly consuming. And for the other one, whatever you are earning, mostly you are saving. Okay.
Yes, ma'am.
Okay. So now there is another part. So if a
Could you explain this graph once more?
both the lines are positively sloped in the graph, both the lines are positively sloped. However, if you consider, yes, your starting point is very high. However, here the MPC, the slope, you know, that is very small. This is for the developed countries. Okay. Or in a particular country, you may consider this is the graph for high income group. Okay. Now, this is the graph where the slope is relatively very high. The slope is relatively very high. That means this curve is also positively sloped. However, it is a very steep positively sloped curve. That means, you know, dc by dy, that is very, very high. Whatever change in income you are facing, that mostly you are spending in consumption. Here the starting point is, you know, from where you are starting, that is very low. That is very low. almost very close to origin. Okay, so your starting point is very low, intercept is very low, however the gradient is very high. That means you belong to a country where the starting consumption is very low, and as income is changing, mostly that changed income is going into consumption rather than savings. Got the point?
Yes, ma'am. Thank you so much.
So coming back to the acceleration principle, if a population's income increases and its residents as a result begin to consume more, there will be a corresponding but magnified change in investment. Now, if people start to consume more, suppliers will get incentive to produce more. If suppliers get incentive to produce more and more, at macro level, there will be an increase in investment. Without more investment, you will be not able to produce more. So, income is increasing. First step, consumption is increasing. That consumption in turn induces or and that results in huge increase in investment. Huge increase in investment. So there will be a corresponding but magnified change in investment. Okay, because we are understanding that there is rising demand for these kind of commodities, you know, and therefore there will be a magnified change in investment. If investment increases because of increase in consumption expenditure, in that case, we can mention this increase as income-induced consumption leading to induced investment or capital stock. So directly government may decide, you know, or the private bodies may decide that we will go for investing this kind of commodities. Here the things are not like that. Here, because of increased income, consumption is increasing, and that increase in consumption itself is putting interest in the mind of the producers to invest more for this kind of commodities or services. So income-induced consumption leading to induced investment or capital stock. This is happening here. Are you understanding this point? Income-induced consumption leading to induced investment or capital stock? Understanding the matter?
Yes, ma'am.
Yes, ma'am.
Here, investment results in capacity creation, and hence the focus of the theory is based on supply side of the economy. Investment we are considering as capacity build creation. Okay, capacity creation. We are creating the capacity to produce more. Investment we are considering in this way. Here investment results in capacity creation, and hence the focus of the theory is based on supply side of the economy. We are trying to improve the capital stock. We are trying to improve the capacity of our production. Okay. And this is naturally based on the supply side of the economy. So if these things happen, we call it acceleration principle. First, income is increasing, consumption expenditure is increasing. That consumption expenditure in turn increases the investment. Okay, so income-induced consumption results in increase in investment or capital stock. This idea is called the acceleration principle. Directly, I am not talking about increase in capital stock for these commodities or these services. Rather, I'm looking at the situation where for the commodities or for the services for which we are finding that as income increases, consumption increases, for those commodities, for those services, we are going to invest more. Magnified change in investment is happening for those sectors. Okay. So this is called the acceleration principle. Second, multiplier. Multiplier measures the impact of fiscal stimulus. Multiplier measures the impact of fiscal stimulus. Are you familiar with the term fiscal, monetary? Are you familiar with the term fiscal? No. Okay. Fiscal means government expenditure, tax, this kind of thing. Okay, fiscal stimulus means through change in consumption, investment, net government expenditure, etc. Monetary stimulus means you will increase the money supply in the economy. In macro, there are two types of stimulus to improve the system. One stimulus can be, you are printing the currency or somehow increasing the money supply in the economy. You are increasing the liquidity in the economy. Money supply, you are increasing. Okay, so this is one mechanism. Another mechanism is fiscal stimulus. You are taking macro policies so that consumption improves, so that there is an improvement in investment, so that there is improvement in government expenditure. You are reducing the tax, you are increasing the subsidy. So all these are fiscal stimulus. So directly you will not increasing the money supply, rather you are taking some certain policies to improve the consumption expenditure or increase the investment expenditure, or you are increasing government expenditure in education, government expenditure in health. So you are taking policies like this to improve the gross domestic product. So this kind of mechanism, which will improve consumption, investment, or the policies which consider the consumption expenditure, investment expenditure, government expenditure, these are called to improve the GDP finally, these are called the fiscal stimulus. On the other hand, you can increase the money supply and you can keep a push, or you can give a push to the economy. Okay, you can give a push to the economy using printing of currency or using the liquidity in the hand of people. Okay, money supply increase. So here, when I am talking about the multiplier measures the impact of fiscal stimulus on GDP. That is, it is, say, del Y by del C, del Y by del I, del Y by del G, all these kind of things. Okay, how GDP will improve, increasing consumption, investment, savings, or government expenditure, etc. Here, the focus is on creation of effective demand. Okay, focus is on creation of effective demand. If consumption expenditure you can improve, that directly increasing the demand in an economy. And if you increase this demand, in the acceleration principle, we discussed how the investment can be improved, or directly you can give subsidy to the people, or directly you can reduce the tax for the people. So in that case, either directly you can improve the government expenditure, or through some indirect mechanism government is spending or taking some policy to improve the consumption or the investment. Okay, so focus is on creation of effective demand, creation of effective demand. I hope you have started to read the ISLM kind of thing. Okay, so IS curve is based on fiscal changes. Investment savings equality curve, it will be related to the fiscal stimulus, whereas the LM, the liquidity preference money supply curve, that will be related to the other part, the monetary stimulus, monetary part. Okay, and I think by 1 or 2 classes you will learn about how to calculate the multiplier 1 by 1 minus MPC. This is the value of the multiplier. You know, if consumption expenditure increases, you know, the multiplier principle shows us how income increases in multiple. You know, suppose consumption expenditure is increasing by 2%, in that case, income will increase by say 20%. So multiplier impact will be there. If you look at the value, you are getting the value is 1 by 1 minus B, your MPC, 1 by 1 minus B, this kind of thing. B is greater than 0, less than 1. Okay, so it is 1 minus half, say. So if MPC is half, in that case, your income will increase by 2%. Okay, because 1 minus half is half, so it will be 2. So if there is a small increase in consumption or improvement in MPC, in that case, you know, your income will increase in multiple components. It will increase by multiplier. So there will be this kind of impact. Therefore, we call this the multiplier effect. Okay, are you understanding? Are you getting some idea about the multiplier? What multiplier does? If consumption increases, investment increases, government expenditure increases, then income increases by multiple amount of the increase in consumption, investment, or government expenditure. Therefore, it is called the multiplier effect. Income increases more. The third concept, already you are a bit familiar with the concept, the cycles, you know, business cycles. When we considered the oscillations, we got this kind of cycles. However, this is the macro context. So in macro context, Sismondi in 1817 first identified that business cycles emerge because of overproduction and underproduction. In this context, I told you we will like to find out the time path of income or production. So there will be an equilibrium level of income. If income moves above this, this is the idea of overproduction. If income falls below an equilibrium level, this we call the underproduction. So if we look at the time path of income, Sismondi for the first time indicated that you will find this kind of circular movement. The income path will go above the equilibrium income, the income path will come below the equilibrium income, and so on. So this is the idea of business cycles in context of macroeconomics. Okay, so these three concepts are very, very important to develop the Samuelson's multiplier accelerator interaction model. You need to understand what is the meaning of acceleration principle, what is the meaning of multiplier principle. So in case of acceleration, we are talking about stock, improvement in stock, you know. And in case of multiplier, we are telling that if you give some fiscal stimuli to the system, in that case, your income will increase by multiple amount. So if you can improve 1% consumption expenditure, in that case, maybe your income will increase by 25%, this kind of thing. If you can improve 3% investment expenditure, maybe your income will increase by 35%. So this kind of thing. Okay, so there is this kind of interrelationship between the thing. If you improve your productive capacity by 5%, your output will increase by say 60%. So this is the idea. Any questions so far? Any question, anyone?
Ma'am, will the induced investment keep increasing with time?
Would you please repeat your question once again?
Ma'am, I am saying as the induced, as with time, will the induced investment increase?
With time, whether induced investment increases?
Yes, ma'am.
Yes, there is a possibility if there is, positive relationship between consumption and income properly. If as income increases, consumption expenditure increases, in that case, naturally production will increase. And for increased production, you need more investment, isn't it?
Yes, ma'am. Ma'am,
So
more
this
investment means more income, and then again more investment. I'm saying like this process.
Yeah. So all this, therefore, it is acceleration principle. It will go on and on like this. Nowadays, if you look at the media, look at the news, you will find that everybody is telling that somehow you have to increase the demand. Starting from, 2000 change in the currency to 2000 rupee. Starting from that, after that COVID lockdown, then again the new COVID cycle. I hope everybody got the idea from the media or different articles that somehow we have to increase the demand. You got this idea? You had this?
Yes, ma'am.
Yes.
Demand. We need to increase our consumption expenditure. Demand should be increased, Somehow you have to improve the demand, okay? So why we got all this message, acceleration principle and the multiplier principle are telling us what are the possibilities if somehow we can improve the consumption expenditure. So there will be some induced investment, which is acceleration principle directly also. If consumption expenditure somehow increases in period 1, in period 2, income will increases by multiple amount of that increased expenditure. Okay?
Ma'am, I have a question. Is effective demand has some other name?
Effective demand?
Ma'am, is effective demand normal demand?
Normally, I your question.
Ma'am, like what is effective demand? Is it like the concept we are studying now, or is it different slightly?
Effective demand is actual demand the market is facing. Effective demand means not the virtual kind of things, okay? The real demand the market is getting. Okay? Not something, which is hypothetical. It's not like that. Effective demand means real demand. Okay? As your macro course goes on, I hope the things will be clearer to all of you.